Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, dalam video kali ini kita akan discuss berkenaan dengan tutorial ataupun exercise AC power analysis. Okay. Ni kita punya exercise. Okay, let's say we have a circuit V voltage supply connected to the Z1, Z2 and Z3. So given Vs, okay, given Vs, Z1 and Z2 and Z3. So the question is find number one, complex power for each load. Okay, complex power for each load. Okay, complex power of Z1, Z2 and Z3. So number two, total complex power supplied by the source. Okay, total complex power supplied by the source. Number three, find power factor of total load. Okay, you need to determine power factor of the load, of the total load. And number four, find the value of C in order to improve the power factor of the total load to unity. Okay, and then in this case we assume our frequency equal to 50 Hz. Okay. Okay, next we look at to question number one. Okay, for question number one, okay, find complex power for Z1, Z2 and Z3. Okay, first of all, you need to determine voltage across every load and current through the load. Okay, for example, for the Z1, voltage across Z1 equal to voltage supply, which is equal to 230 angle 0. Okay, so in this case, we have a VRMS voltage. Okay, we have a VRMS voltage as given in the question. Okay, VRMS. Okay, then we can determine current. Okay, I1. So I1 equal to V1 over Z1. Okay, V1 over Z1, and then you can get RMS current. Okay, because VRMS divided by Z, and then you can get IRMS. And then once you got V1 and I1, so you can determine S1, because S complex power equal to VRMS times IRMS. Okay, VRMS times IRMS conjugate. IRMS conjugate. So you can get S1. Okay. And then next you can determine Z2. Okay. You can determine complex power for the Z2. So in this case, you need to determine voltage across Z2 and current of the Z2. Okay. First of all, you determine the voltage. Okay, how to determine voltage of Z2? You can determine according to the voltage divider. Okay, voltage divider. Since we have a voltage across Z2 and Z3 equal to V1 or equal to V, so VZ2 equal to Z2 divided by Z2 plus Z3 times V1 times V1. So you can get V2. You can get V2. Okay, RMS. Okay, so current I2 equal to I3 because we have a series connection between Z2 and Z3. So we have the same current. So V2 divided by Z2. Okay, V2 divided by Z2. So we got a current. Okay, so this is a RMS value because we have a voltage. Because we have a RMS voltage. Okay, and then after you got a current and voltage, okay, of the Z2, so you can determine the complex power. Okay, V2 RMS times I2 RMS conjugate, and then you can get current. You can get complex power. Okay, so next for the Z3, okay, similarly to Z2, you need to determine a V3. Okay, by using a voltage divider. Okay, Z3 divided by Z2 plus Z3 times V1. Okay, and then you got a Z3. Okay, RMS voltage. Sorry, you got a V3 RMS voltage, and then you can determine S3 because VRMS V3 RMS times I3 RMS conjugate. Okay, we know that we have a I3 equal to I2 because we have a series connection. We have a series connection, and then you can get S3. Okay. Okay. So total complex power. Okay. Next question, determine the total complex power supplied by the source. Okay, total complex power supplied by the source. Okay, how to determine total complex power supplied by the source? Okay, we have several approach. Okay, approach number one, you can determine a voltage and current, then you can calculate complex power supplied by the source, or you can determine the total complex power supplied by the source according to the conservation of complex power. Okay, because complex power supply equal to complex power, okay, of the load. Okay. Okay, in this case we use the approach number one. Okay, so complex power supply by the source equal to Vs RMS times Is RMS conjugate. Okay, conjugate, this is RMS value. Okay, so then you can determine Is from the circuit. We know that Is equal to I1 plus I2. Okay, according to the Kirchhoff current law. Okay, this is a RMS value. Okay, so S supply equal to VRMS times Is RMS conjugate. Okay, conjugate. So you can get a S supply. Okay, this is the complex power supply by the source. Okay, this is approach number one. Approach number two, you can determine based on conservation of complex power. S supply equal to S1 plus S2 plus S3. Okay, so we have two different approach. Okay. Okay, next, the last next, power factor. How to determine power factor of the total load? Okay, so we have a S supply, we have a magnitude. This is a apparent power, and then this is a angle of power triangle. So power factor equal to cos theta. Cos theta. Okay, so 0.943. Okay, lagging or leading. Since we have a S supply is positive angle, so our, which is you have a P and positive Q. Okay, we have a P and positive Q. So positive Q means we have a inductive load. So for inductive load, we call it a lagging power factor. Okay, that's why we have a lagging power factor. Then the last one, okay, find the power factor correction. Okay, sorry, find the value of C, find the value of capacitor in order to increase our power factor to unity. Okay, in this case, we assume our system frequency equal to 50 Hz. Okay, so we have S total. Okay, we have S load, which is equal to S supply. So, and then in order to improve the power factor to unity, we need to connect our capacitor in parallel with the total load. Okay, we need to connect here, for example. Okay, so okay, previously we have a power factor equal to 0.943, so we need to increase to 1. Okay, so for example, we need to increase to 1. So S load equal to S supply according to the conservation of complex power. So this is our, okay, total complex power of the load. Okay, then you can convert to the rectangular form. We have a P, real power, P, and then we have a Q, reactive power of the load. Okay, when you draw the power triangle, we'll come draw the power triangle. Okay, we have a P1, Q1, okay, S load. Okay, this one power triangle without capacitor, this is original power triangle. Okay, in order to improve power factor to 1, what is the meaning of power factor to 1? We need to compensate all the Q1. Okay, So your Q2, your final Q, your final reactive power, which is equal to 0, which means our theta 2 equal to 0. Theta 2 equal to 0. So our QC equal to Q1, this is our original reactive power, minus Q2, okay, our final Q2 equal to 0. So our QC in this case equal to Q1. Okay, our QC equal to Q1 minus Q2, which is Q2 equal to 0. And then this is our QC, okay, 1877.45 volt ampere reactive. Okay, this is our QC. So from QC we can determine C, because we know that QC equal to Vrms square divided by XC. So in this case XC equal to 1 over omega C. Okay, by solving this equation you can determine QC. You can determine C, which is QC over omega Vrms square. Okay, and then you can solve this one. So you got C equal to 112.96 microfarad. Okay, so that's all for tutorial or exercise chapter 5, complex power. Okay, Assalamualaikum warahmatullahi taala wabarakatuh.